Hi, I'm Pat Hindle with Microwave Journal. I'm here at IMS 2023, talking with Steve Dudkiewicz, Vice President of Marketing and Business Development. Steve, you have quite the display here. I think 12 demos.
Yeah.
Maybe you can tell us about some of them and take us on a little tour.
Absolutely, Pat. Thanks for stopping by. Like Pat said, we're here at IMS 2023, and we have an 800 square foot booth that we've equipped really like a customer lab. If you just take a quick look around us, what you see is 12 demo stations. Each demo station is an embodiment of what one of our customers would use in their typical test and measurement lab. Why don't we come on a tour? Let's start over here on this side. People always ask about cables and they say, how do I know what the right cable is for my application? My first question to them is, what's your application? So we've actually chosen two of the most challenging applications, one being a gimbal that would go into a chamber to test antennas and over-the-air measurements that is constantly rotating, and you can see that the cable is being bent in all different ways. What we're showing here on the computer is that our cable has relatively little change or impact on that signal, resulting in high-quality measurements. The second application that we're showing on the left-hand side, our cable is connected to an automated impedance tuner. When you go and you use a tuner to tune an impedance, it gets impacted by the cable. And what we're showing is that our cable offers some of the lowest change possible. Next is our MT2000 mixed signal active load pull system, which is doing 5G modulated wideband impedance load pull on a small LNA. Most of our customers who are using this are designing 5G base station or handset power amplifiers. This demo is in conjunction with our partner AMCAD Engineering based out of France, and what it's showing is a power amplifier circuit tuning and optimization station under digital predistortion conditions. This is similar to what would actually go into a base station, and we're allowing customers to test their designs and see if it works for that base station application. Moving on to this station, what you'll see is active load pull measurements, which is a little bit different take on load pull. These are active load pull measurements, but here the difference is we're doing it at 140 gigahertz. This solution works equally well at 200 gigahertz, 300 gigahertz, 500 gigahertz. We even have a customer using it at 750 gigahertz. It's a lot of gigahertz. It works in theory up to 1.1 terahertz. I've not seen it yet, but I'm sure we're going to get there. Moving on to this station, you actually see an advanced channel emulator. This is used for satellite communications, and it mimics the impairments that would be caused in nature. Things like when one satellite is moving over a fixed ground position, or two positions are moving against each other. This box can mimic that and tell you how your modem will behave. This is from our subsidiary DBM, based out of New Jersey. And they're showing here for the second year at IMS. Moving across to this station, we actually are showing our newest miniaturized automated impedance tuners. They're called the Nano 5G, and they were designed specifically for on-wafer load pull measurements at 5G FR2 frequencies. That's 28 and 38 gigahertz. What you'll see about this is because they're so small, they can be integrated directly at the probe on probe stations. And you'll have two probe stations here. The first one is from our partner Form Factor, and the second one is from our partner MPI. Let's move on. We've spoken a lot about load pull in all these different stations. Now we're talking about the fundamentals of impedance tuning. Impedance tuners are used to vary the impedance and perform load pull. And here you see three different variations. The first is the simplest, and it is a triple stub tuner. It's the most cost-effective and manual approach to tuning. The second is a manual slide screw tuner, a little bit more costly, but a lot more fine-tuning capability on how you do load pull. And finally, our automated impedance tuners for lower frequencies than Nano 5G, but to serve the same purpose, load pull in an automated fashion. These two solutions are from our partner AMCAD Engineering, again in France, and it actually starts over here on the left-hand side with an ATE automatic test system. This is used to test multi-port circuitry like you see here with the end goal of creating models. Moving to the right, it's actually a simulation platform created by AMCAD Engineering to simulate advanced systems, including 5G systems. Here they're showing a dashboard for DPD simulation, taking the measurements and the models from the ATE system.
So
This is another variation of our MT2000 system that we spoke about earlier, but this is our highest frequency unit to 67 gigahertz. It is a turnkey active load pull system that's able to perform harmonic load pull measurements at frequencies up to 67 gigahertz under modulation bandwidths up to 1000 megahertz. Here we're actually doing a mixer load pull measurement where the input and output frequencies are different. This is a new application being launched at IMS this year. Our final demo station is our latest pulsed IV load pull solution, which actually performs pre-pulsed RF measurements, and it's used to develop more accurate and faster compact transistor models. This is another new solution for IMS this year. So that's it, 800 square feet, 12 demos. Thank you so much for taking this tour with us.
Steve, that was quite the tour. You guys are really offering a lot here. So how has the reception been from everybody visiting?
Oh, it's been packed. It's been great. The feedback is wonderful, and we're looking forward to speaking with customers afterwards and helping them solve their problems.
And where can they find out more about all these demos?
Contact us, maurymw.com. Hope to hear from you soon.